this video we're going to consider the graph of y equals root x. So let's just go back to a previous video that you may have watched on the graph y squared equals x. This graph considers the upper and the lower arm of this graph as two separates. So if I was to look at the upper arm only, this is the graph of y equals positive root x. And obviously if I then look at the graph of just the lower arm, that's the graph of y equals minus root x. And in this video we're going to study these two arms separately, not together. Now I'm going to write down the general transformation of that graph in terms of a, h and k, because we're used to working with a, h and k. Generally, any transformation of this graph looks like this: a square root of x minus h. Now that's not technically in brackets. I like to keep it in brackets just because it tells me that that's all underneath the root plus k. As always, when we're going to find our value of hk, which would be, if it was all together, the value of the turning point, then you've got hk being that point. All right, a is the dilation factor, h horizontal shift, k vertical shift. All right, let's get straight into an example. We're going to try and sketch a graph. I'll just clear some space. All right, so I'm going to sketch the graph of y equals 3, so it's a positive, there's no negative value of a, so we're looking only at the upper arm of this graph, times the square root of x plus 1 at minus 6. Now let's just remind ourselves that that could be in brackets, so we change the sign for this. So therefore our a is 3, our horizontal h value is minus 1, and k is minus 6. So we know that if we were to draw the whole thing, the turning point would be at minus 1, minus 6. So hk is minus 1, minus 6. Now when we're sketching, we should always have those three headings. The x-intercept occurs when y equals 0. The y-intercept occurs when x equals 0, and that hk. So we can put the hk in straight away. We know that that's minus 1, minus 6. Let's look at the x-intercept. So I'm going to sub in when y equals 0. 0 equals 3 times the square root of x plus 1 minus 6. Add the 6 first, divide by 3 if you like at the same time, gives you the square root of x plus 1. 6 divided by 3 is 2. 2, and then I can just square 2 to give me x plus 1 to undo the root. 4 equals x plus 1, which means x equals 3. I'm subtracting 1. Let's look at the y-intercept. Remember, we would normally have 2, but because we're only doing one arm, we only want the positive one. So let's have a look what they would be. When x equals 0, we get y equals 3, bracket 0 plus 1, take 6. 0 plus 1 is 1, square root of 1 is 1, so 3 times 1 is 3, take 6. The y-intercept is minus 3. Now when I sketch that, I'm only after the upper arm, so I'm going to sketch it down here. Always put your x and y axes, and I know that my y-intercept is, hang on, I get to, minus 3. My y-intercept is minus 3, so that's where I go like that, at the turning point. Does that make sense? Yep, the turning point would be at minus 1, minus 6. Obviously, minus 1, minus 6 would be down here, so that makes sense because it would come down and turn around. I don't want that bit. The x-intercept is positive 3, so that makes sense. And we just put the title of the graph, so we've got y equals 3, square root of x plus 1 takes 6. Let's do a second example. This one, you'll notice this equation here, where the value of a is negative. That means we're only interested in the negative arm of the graph y squared equals x. So we're just going to have a graph that looks like that. So let's work out, okay, let's find the x-intercept when y equals 0. 0 equals minus 2, square root of x minus 1 plus 3. Subtract the 3 and divide by the negative 2 at the same time. Just leaves me with the square root of x minus 1. This becomes positive anyway, so it's 3 upon 2 equals the square root of x minus 1. Let's get rid of the square root sign by squaring, so we get 9 over 4 equals x minus 1, and then add the 1 over to give us 13 over 4 equals x. So our x-intercept is 13 over 4. Let's look at the, that should be y-intercept there. Y-intercept occurs when x equals 0. Let's try that again. Let's put when x equals 0 in there. We get y equals minus 2 bracket 0 minus 1 all square rooted. Plus 3, work that out. Minus 1 square root. We can't square root minus 1, so this is going to have no solution. Now let's see if that makes sense. The value of hk is h is 1, k is 3. Therefore, the actual turning point, if I was to draw that whole thing, sits this side of the y-axis. So therefore, it's not going to cut the y-axis. So if I sketch just the lower arm, I only want the lower arm because it's the negative, I'm going to go here. So this obviously would be the value of 1, 3 here. Our y-axis, our x-axis. The x-intercept was 13 over 4. Obviously that's continuous. And that is the graph above, which would be titled for this, y equals minus 2, square root of x minus 1, all plus 3.